This section is about part drawing. In this case, we have a valve that we have to draw. This is a full part, but this is the section view, so you can see the different dimensions. So imagine it like a fully cylindrical part. And in these kinds of drawings, we have to use a title block, which gives more information, and this needs to be filled in according to the specifications of the part. So let's rename this to the actual name. Double click on it, Control A to select, backspace to delete, and write in valve. Click outside, and we have the name inserted. Now we have to also fill in all the other blanks. So with the information filled in, we can move on to drawing, but also we can consider updating it as we draw. So this is an A4 sheet of paper, and the scale will be a 2:1 scale, an enlarged version of the part due to its small dimensions. So the overall size of the part at 2:1 scale will be 44, 40, and 40 again. Due to the nature of the part, we will have two views. One will be a front section view, and the other will be a side plane view. So we'll have two rectangles positioned side by side. I placed the two rectangles here. A is 32 and B is 103. And this is 44 over 40, and this is 40 over 40. I place the axis lines. For the section view here, we have only one vertical axis line, which is in the middle. And on the side view here, we have two vertical and one horizontal and one vertical axis, which are also in the middle of the rectangle vertically and horizontally. When you look at the part from the side, this side, you have 4 circles to draw. The largest one is 20 and the smaller one is 13. But because we are drawing at a 2:1 scale, these will be for us in our drawing radii, not diameters. So one circle here, diameter is 40, the largest one. Another circle, the diameter is 26. Additionally, we have against the diameter of 13 a chamfered edge of 1.5. So it gives us an extra circle with a diameter of 15. But since we are actually 16, but since we are at a 2:1 scale, we'll draw with a diameter of 32. And for the other dimension, so we have a circle outside of 20 in diameter, and we have a chamfered edge of still 1.5 edge, 1.5 times 45. So that means that the inside one is 17, but we have to double that because we are a 2:1 scale. So that makes it 34. Diameter is 34. So if we look at the part, we see that the first length here is 10 millimeters. So we want to start drawing the section view here. And this 10 millimeter line is with a diameter of 20. So we multiply that by 2. So we have a rectangle which can be built with the rectangle command, starting from here that goes 20 to the right. So at 20, comma 40. And this is to denote the projection of this cylinder here. After that, the next 12 millimeters should be of a diameter 18, but it is inside, so the 12 millimeters go for 30, like 18, but from 9 against the axis line, 9 towards the top and 9 towards the bottom. But since we are a 2:1 scale, then this has to be 36, and that 12, which is the difference between the largest dimension and the 10, that 12 will be 24. So we want to go 24 to the right, and we also want to go towards the top 36. So we create another rectangle from here, and we give it 24 to the right, and then 36 towards the top. And now we have to move it, because this is 36, but we have to move it 2 millimeters towards the top. So we'll move it with the move command. Type in move, enter, click, enter, give the base point to be this, and then just type in the add symbol 0, 2. And that means that from the location where I picked up the object, move it 2 millimeters towards the top. And now I have 2 millimeters on the bottom part here and 2 millimeters on the top. Now these rectangles helped me to build my outer outline, but I don't need these extra lines here, so I'll have to explode the rectangles, and then I'll select these 2 lines here, but careful not to delete everything, so better to trim them. TR, double enter, and select here, and since they overlap, I have to click 2 times, and here as well, because there is an overlap. Now, since this is at 45-degree angle, okay, and we have the diameter of 18 here. Also, we have 22 and 18, which denotes the base and the top of the part of the chamfered edge here. So that means the chamfered edge is at an angle of 45 degrees with a length of 4 due to the difference in these dimensions. So 4 times 45 degrees. So I can give the chamfer command here, and then angle, and then 4, and then 45, and then go here and click on these 2, and repeat chamfer angle. But what did I forget? I have to multiply, because it's at a 2:1 scale. So the angle remains the same, but my 4 millimeter chamfered edge needs to be 8 now. So chamfer angle 8, 45, then go here and click here and here, and then do the same for the bottom part. Chamfer angle 8, 45. Now we can do the same for the outside edge here, which is the chamfer at 1.5 times 45 degrees. So we multiply that by 2, and we chamfer the edge at an angle with the dimension of 3 at 45 degrees. And we have this one and this one, and repeat for the other side, this one and this one. Okay. Now, considering also that we have a radius here of 1 millimeter, we have to round out this edge here with a radius of 2 millimeters. So we give the fillet command, radius 2, and and for multiple, and then we can click on these edges here to round out the geometry. Now for the inside wall, we can look at this dimension here. We have a 16, that is from the edge towards the right until the wall begins. So we'll offset by how much? 32 towards the right, like that. And now we want to create the inside wall for the vertical and horizontal part, these two. And this happens to be the smallest of the circles that we created here. So we can zoom in, give the X-line command here, hold shift, click, enter, and repeat for the bottom. So X-line, shift, click, made it vertical, but no problem. Try again. It snaps to different things, so click on the ones I don't need. And now here on the other side, I just create a line to join these two together. Here as well. And I no longer need these. Can delete them. Now I can work a bit more here on the inside wall. So I can trim this part here and here. And also I can chamfer the inside edge like it is here. So chamfer angle 345 and click on these two. And the same for this side. Chamfer angle 345. This is because I used the line for the rectangle, so I'll Control Z. And the first one got deleted because it was used to chamfer the first edge. So chamfer angle 345, like that. And because I chamfer this edge, we have one edge for the base of the chamfer and one edge for the top of the chamfer here. I also have to place an axis line at 14 from the left, so I can create the 4 holes required of a diameter of 2. So I can offset by 28 this line, and this should be my axis line. So this is on the axis layer, and I need to extend that, extended so for the moment I'll leave it like that. And now, because of the section view, I have one of the holes is not visible because it's cut off, and one is straight on, you can see it, and then the other two, they are cut through. So one circle here to denote the first hole, which is visible, with a diameter of not 2 but 4, and the other two will be with the X lines from the quadrant here, like that, and like that. And now I just need to draw these lines here. And here. And remove the two X lines. I also need to trim the axis line a bit. Here and here. Just need to extend it 3 millimeters here. Let's try to trim it here as well. Oh, it got erased. So trim this part here. Okay. And extend this by 3. Like that. Now we have to trim these two. And we also have to trim these two and deal with the intersections that happen here. As you can see, they are not straight lines because they have two cylinders that intersect each other. So they should be, here you should have some curved lines. Let's consider that we have this projection here, and we also have these two holes here. So because this is a section view, we no longer need to draw the hidden edges for the holes. But if we wanted to draw them, it would be 2 to the left and 2 to the right. So we can offset for 2 millimeters this axis line just temporarily. So one to the left and one to the right. And their projections, which would have been hidden lines, would have been here with hidden lines, the projection of the hole. So based on that, we can see that there is a difference in height between the top of the cylinder and the base of the hole. So based on that, we can build a construction that will help us to draw our intersections here. And we do that by giving the X-line command, and then we don't have anything to do with the largest diameter, but the next one. So we need like the diameter of 18 practically. So let's see which one should build like another circle here with a diameter of 36. This would have been this hidden edge here. And now from this we'll give the X-line command, hold shift to draw a straight line like that. Okay. But actually we have to delete this and we have to look here and see where the circle of 36 intersects these two lines. So we have the X line and it should be from here. So this intersection point. And hold shift to make it straight. So you can see it's a difference in the height there. and it translates to that not being a straight line here. So this won't be a straight line. And this won't be a straight line. Okay. And the other one on the bottom corresponds to the smallest circle here. So the intersection between the smaller circle and the vertical line here, we'll do an X line again here, like that. And as you can see here, this is the point of maximum for some arcs. So we'll draw the arcs here. They start from here. They have a base here, and then the last point is here. Okay, we can delete this. And similarly here. We'll give the arc command, click here, here, and here. Change, we'll also delete this X line as well. And we'll change these to be on the proper layer. And similarly, we can do this here as well. So one X line from here. And another one from here. Give the arc command, this point, this point, this point, and here have this point, this point, and this point. And we'll delete this X line here and this X line here. And we'll place this on the proper layer. That is the thick lines layer. Now we can also delete these lines. We just needed them to build, and also the other circle here. Now we can move on to create a new layer for the hatch pattern, the continuous line, and should be thin. So let's place the hatch pattern here. Hatch pattern should be here and here, and here, and also here, and enter. And it's too too close together, so I'll give the hatch edit command, click on this hatch pattern, and from the scale here we'll set it to 15, and the hatch pattern looks better. And we have to change it to our hatch layer. So on the home tab here, move it to the hatch layer so it is with the thin line. Looks like we have everything placed, so we need now to go to our layers menu and activate the dimension layer. Also, let's quickly style. So style this from the symbol here. We need our arrows to be 3. Our center mark should also be 3. Our text here should be 3.5. Should be above the dimension line. This offset should be at 0.7. This should be aligned. In the fit tab should be both text and arrows. We have to check both of these. And primary units should be set to 0. Okay. And what about our lines here? It's okay. So, okay, and close, because this is the current layer. So now we can dimension. We are on the dimensions layer, so let me place this dimension here. It should be 10, but it's 20 because we did it at a 2:1 scale, remember. And from here, this should be 14. From here to here, this should be 16, but it's double. And then from here to here, should be 22, but it's 44. Okay. We also have to dimension this with dim dia here, and should be 2, but it's 4. And we have to place the number as well, so 4 times 5, 4, because there are 4 holes in total. We also have a dimension here from here to here. Oh, I already placed that one. Have the diameter, so dim dia, this one. So this diameter should be the 20 here, but it's 40. We also have to add in G6 here. And we also have to dimension the smallest circle, so dim dia, the smallest one. Place it here. Now we also have the chamfered edge here. We need to dimension this as well. So leader, from here, want to go like that. So that will be at 7 less than, and this is 225. And then go to the left here. So at -2, 0, enter, tap enter again. It should say 1.5 times 45% %D, and tap enter a few times. finish dimensioning that. I also have here a diameter of 18, but it's seen as a line, so DIMLIN. Click on this and that and place it somewhere here. And I can also add by double clicking on it the diameter symbol, which is %%C. And now I also have to add in the chamfered edge here. So I can either add a leader line like this, or I can use the angle to specify it. And I can see I'm also missing a dimension here. So I'll have to first get this a bit towards the top and dimension this as well. So from here to here. Okay. This 36 is my 18 from here. So my 18 millimeters here. So I decided to dimension the angle here. So from here to this line, I can give the dimension like that. And I need to kind of move this so they don't intersect with each other, and try to adjust so that I don't get too many intersections. The idea is that the dimensioning needs to be as clear as possible, and we have to remove all of the uncertainties regarding the dimensioning. So I'll need to draw a helping line here to indicate that this comes from here. And also I may want to place it either inside or outside. It should fit, but the space is a little bit small here. I'll try not to intersect with anything. Since this part is so small, we can even decrease the text size a bit so we can help ourselves not intersect so much. So let's decrease that from the style manager here. So the text, let's put it at 2.5, and we should also change the arrow size to be at the 2 millimeter value, and also the mark here. Okay, and let's see what happened. It's much better now. We also need to dimension this radius here, so we use the DIMR, so DIMRAD command, and click on the edge here and try to adjust it so it doesn't intersect. And also it doesn't like fit perfectly vertical or horizontal. Remember, that shouldn't be the situation. And now we have to check if we have all of the dimensions by looking at our dimension part and looking at our own drawing. What we can see is that the dimensions here are doubled the dimension that we require. So we can try either to go and double click on each of the dimensions, delete the value from the dimension and add in the proper one, or we can go to the style manager, the dimension style manager, and in the primary units tab, we have here something called measurement scale, and we can set that to a scale value. So see, we have here it's 44. If we set this to 0.5, that means half, then this divides everything in half, including our radius here, and our leaders remained untouched because they were inserted manually, but everything else that was dynamically inserted got sliced into half, even the 520 here, which was 40 before, and 13, which is 26, and everything is now scaled according to the 2:1, so the shape, the dimensions of the shape of the drawing. This is at 2:1, so it's enlarged, but the dimensions themselves, the measurements here, the values placed on the dimension lines, are the ones corresponding to the real part. So this is how you use the scale and how you think about enlarged scales. So now let's give the plot command, and in the plot window here we can select our printer. I'd like to select AutoCAD PDF high quality, and our sheet size needs to be ISO. It should be A4 and should be in a portrait fashion. This should be centered. This should be a window. I can select from here to here. So from there to 0, 0. And I'll make sure that my scale is 1:1. And now I'll click the preview. I can see I have an error with the layout, so I'll tap escape and go here and change this to portrait mode. Now when I click the preview button, the drawing sheet here is ready for printing, and if we zoom in we can see a line difference and we can now click OK, and we'll save this. And as you can see, now we have a drawing that's ready to be printed on our printer.